So check it out, I bought a new toy. It's a Mac Studio with a ton of memory, and I'm interested in running a really big large language model. So normally you would need an expensive Nvidia card to run these things, but I want to see if a Mac Studio can handle it instead at a fraction of the price. Since I'll be running such a big model, I'm also curious about a few things, like how much power will it use? Is it going to get too hot and shut down? And I'm also curious how loud it'll be, and if the fan will be running constantly. Let's start with the hardware. I'll be using a Mac Studio with a 14-core CPU and 40-core GPU. I want to run really large models, so I went with 128 gigabytes of RAM. And by the way, if you're on a budget, you really don't need that much memory. I've had pretty good results using a MacBook Pro with 32 gigabytes of RAM. You just have to use a smaller model. For a size comparison, here's the Mac Studio sitting next to my B-Link servers. One of my goals is to run AI agents on my home lab, but instead of using a cloud AI service like Claude, I want my agents to communicate with the Mac Studio instead. To make that work, I have to set up local networking. This process is pretty easy. I just have to connect my Ethernet cable to the back and plug the other end into my switch. Okay, I'll hop on my Mac Studio and start by installing an app called LM Studio. First, let's go to the website and click the download button. In my case, I'll be installing the Mac OS version. Oh, there's one thing I want to point out. During the installation process, I selected Developer to expose all the options. This will be useful when exposing your LLM as a service. Once everything is installed, let's open it up and take a look. The first thing we want to do is download a model. On the upper right-hand side is an icon called Model Search, and I'll search for GPT-OSS. And I'll click 120B, which is the 120 billion parameter model. That's the really big one. In this case, I'll be selecting the GGUF version of the model, and then I'll click Download. Once the model is downloaded, let's test it out. I'll click the chat icon, and then at the top, I'll select the model. I'll slide the context length all the way to the right. And by the way, if you don't have enough memory, you'll get a warning. And in that case, just slide it back until the warning goes away. Finally, I'll click the Load Model button. I'm going to make the prompt pretty complex, and that should give me some time to take a few measurements while it's running. Things like power usage, temperature, and noise levels. For the prompt, I'm going to combine two topics, healthcare and programming. I'll ask it to first create a healthcare document using a complex standard called FHIR, and then I'll process a claim using some custom Rust code. While it's processing, I'll start to take those measurements. Let's take a look at the power usage. For the GPT-120B model, I've been getting an average of about 150 watts, which is quite a bit lower than I was expecting. Next, let's take some temperature readings around the case. And again, this is a lot lower than I was expecting. In terms of sound, the fans have been really quiet when running this model. And here's some of the stats from the activity monitor. It looks like the model is using about 70 gigabytes of RAM and very little CPU usage. It looks like the model mostly runs using GPU, which makes sense. Going back to LM Studio, you can see the token count. For the 120B model, I've been getting roughly 70 to 80 tokens per second. The smaller version of the model, called 20B, seems to run a lot faster at about 100 to 120 tokens per second. Okay, let me show you something cool. I'll open up a new chat, and this time I'll use a smaller model called Medgemma 4B. So what makes this model special is that it's trained against healthcare imaging data. At the bottom, you can see a vision icon, and if I add an attachment, we have the option to select an image. I'll grab a chest x-ray that I found on Wikipedia, and then I'll open up the file. In the prompt, I'll ask it to describe the image. Then I'll ask it to expand on the hazy markings. So this is pretty cool. We can use both text and images as input, if the model supports it. Next, I want to show you one more model, and I think right now it's my favorite. It's called Devstral Small 2. And I've run this model on a MacBook Pro with 32 gigabytes of RAM, and the results have kind of blown me away. It has a really large context window of 300,000 tokens. So here's an example of what it can do. So up to this point, I've been running all the prompts directly on my Mac using LM Studio. And this is great, but if you're developing software, you really want to access your AI models using an agent mode. And this will allow your model to view all your files and load them into the context. It'll also allow you to create and modify your files. To do all these things, we really need to run LM Studio as a server. Let's start by clicking the developer icon on the upper left-hand side. I'll then click this slider button to start the server. The IP address of my Mac Studio is 192.168.3.23, and the server will be running on port 1234. So I can use the IP in the port to connect to the LLM remotely. I'll use my MacBook Pro as the client, and to connect to the server, I'll use a VS Code plugin called Continue. Assuming you already have VS Code installed, click Extensions on the left-hand menu, then search for Continue and click the Install button. To run the extension, click on the Continue button on the left-hand menu. The first thing we'll need to do is point to our server by setting up a config file. To do that, I'll select the config dropdown at the top. Then I'll click the little gear icon on the right side of configs to bring up the config file. I'll paste in a sample config file to get it started. And by the way, I'll have all the instructions and configurations for this video on my GitHub page, link in the description below. Okay, under Models, you can configure each model that you want to access. At the top, I have the first model configured for that GPT-120B model. The name can be anything, and provider should be LM Studio. For the model, we'll have to go back to LM Studio to figure out what the name is. In LM Studio, click the Developer tab on the left-hand side, then load a model. Next to LLM, you should see a model name. Now I can jump back to my MacBook Pro, and you can see that the model name matches the value from LM Studio. You also have some additional settings. Context length is important and should match the size of the context you set when loading the model. The roles and capabilities are kind of like access controls. Apply, edit, and tool use will let us view and modify local files. Now for a quick demo. I'll create a new chat and select the model, then I'll make sure I'm in agent mode. Next, I'll ask it a question about networking. Just a reminder, I'm running this on a MacBook Pro, and the laptop is talking to my Mac Studio, which is acting as a server. And the important point here is the Mac Studio is completely self-contained. It's not reaching out to the internet to pull this information down. Finally, I want to try something a little more advanced. First, I'll select a folder in VS Code that points to some application code. In this example, I'll use a Java app. The idea here is I want to use that entire folder as context for my prompts. Okay, let's start a new chat. I'll ask it to view all the code from the folder, and to do that I'll use the @tree and then ask it to describe the application. Then I'll ask it a question about the code. I'd kind of like to know what are the Java dependencies in the application. Okay, and then finally I want to show you how we can create a file. I'll ask it to create a new file called example.json with some random contents. And then I have to accept the changes. And there it is, it created the file. Okay, that was pretty cool. I now have an AI server that I can use for my bare metal cloud. So what do you think? Is it worth all the hassle to host your own models? Let me know in the comments below. And as always, thanks for stopping by, and I'll see you in the next video.